Hello everyone. So in this video we would be discussing the final 10 questions of IBSL 2020 chemistry paper 1. So that is from question 21 to question 30. So let's start our discussion with question 21. So in this question it is given that iron is a stronger reducing agent than silver. That means it basically means iron will get oxidized and silver will get reduced. Okay. So we need to find out which of the following is a correct voltaic cell when operation. So iron is getting oxidized. So whichever stuff which gets oxidized is present at the anode, and the stuff which is getting reduced is always present at the cathode. Okay. So at the anode it will be iron, at the cathode it would be silver. Now we need to find out the direction of electron flow in the wire. Okay, so silver is getting reduced, so that means basically Eg plus electron is producing Ag. This is the reduction reaction, and iron is getting oxidized. That means Fe becomes Fe2 plus and gives out 2 electrons. Okay, so what happens is electrons are produced here, okay, and electrons are used up here. So that means that these 2 electrons, electrons are produced at the anode, okay, and they are transported to the cathode. So the electron flow is from this is the right side and this is the left side. So it's from the right to the left side. So this is our final option. So our answer is option D. All right. So moving on to the next question. In this question, we need to find out which of the following is correct in an electrolytic cell. Okay, not an electrochemical cell, in an electrolytic cell. Obviously, we know that at the anode, we always have oxidation. And in the cathode, we always have reduction. Okay, so from this information, we can say that option B and option D are not correct, because at anode there should always be oxidation and at cathode there should always be reduction. So in the process of oxidation, we know that electrons are lost, while in the process of reduction, electrons are gained. Okay, so obviously this also rules out option A, and we are just left with option D, which is our correct answer. Now in this question, we need to find out the oxidation states of oxygen in the following compounds. In O2, the oxidation state of oxygen is 0, because oxygen is bonded to oxygen itself, and we know that when a compound, when an element is bonded to the same element, its oxidation number is 0. Okay, so our options A and D are out. Okay, it would be either option B or C. And OF2. In OF2, what happens is fluorine is more electronegative than oxygen. So fluorine would be assigned a -1 oxidation state. Okay, and as this total molecule is neutral, oxygen will have a +2 oxidation state. So this thing is correct and this is correct till now. Okay, we can also do it algebraically. Let's say the oxidation state of oxygen is X, and for fluorine it's 2 times -1. Okay, and it's 0 as it's a neutral molecule, so X becomes +2. Finally, for H2O2, let's assume that oxidation number of oxygen is X again. Okay, so 2X plus oxidation number of hydrogen is always +1 is equal to 0. It's not always, like it is when hydrogen is attached to a non-metal, it's generally +1. So from here, X becomes -1. Okay, so from all this, option C is the correct answer. Now on question 24, we need to find out which of the functional groups are present in this molecule. Firstly, let's identify the functional groups. We have CN here, this is a functional group, we have this group, and we have this group. Okay, firstly, this is a ketone group. Okay, ketone is basically a carbonyl group. Okay, this linkage is known as an ether linkage. So here, this is an ether. Okay, and CN is basically a nitrile group. So option A is the correct answer to this question. Now in question 25, we need to find out which of the following molecules will decolorize bromine water in the dark. Okay, so to answer this question, we need to know that unsaturated compounds can only decolorize bromine water in the dark. That is what are unsaturated compounds? They are basically compounds containing double bonds or triple bonds. Okay. So in this list, cyclohexane doesn't contain any double bond or triple bond. It looks something like this. Hexane is this thing. So again, hexane doesn't contain any double or triple bond. Hex 1N is interesting. It has one double bond, and hexane 1-ol is basically this thing. Okay, so out of all these four options, only hex 1-ene has a double bond. Okay, or hex 1-ene is unsaturated. So option C will be our correct answer. Now for question 26, we need to write the IUPAC name of this molecule. Okay, so for this, let's start numbering this molecule. We can number from this end, because you see, when we start numbering from this, a lot of substituents come at lower locants. Okay, so this is 1, this is 2, 3, 4, 5, 6. So this is a hex chain. Okay, so our word root is hex. So double bond is present at the second position. So hex 2-ene. Okay, this is our suffix. And for the substituents, so at position 2 there is a methyl group, position 3 there is a methyl group, and at position 5 there is a methyl group. Okay, so it's 2, 3, 5 trimethyl hex 2-ene. So for question 26, option D is the correct answer. Now for question 27, we know that benzene is really rich in electrons. Okay, so every benzene ring has a good amount of electrons within itself. Okay, so benzene is really good for electrophiles. So what are electrophiles? Electrophiles are species which are electron deficient, okay, or which needs electrons. Okay, species which are looking for electrons. So the best mechanism for benzene is obviously electrophilic substitution reaction. Now moving on to question 28, this thing, let's write the formula first. We can write the relation. Okay, now as C is a constant, this thing will be 0, and we need to find percentage uncertainty. So we need to find this thing. So this is basically delta M by M plus del of delta T by delta T times 100. Okay, so delta M here is 0.2, M is 20, del of delta T, that is 1, and our delta T is 10 times 100. So let's cancel this out, and this will be 1.1 times 10, so answer is 11%. That is option C. Now to find IHD, as in question 29, we have a generalized formula. Okay, let's say this is our molecular formula, that is CC HH NNOOXX. So for this formula, the formula of IHD, okay, would be half of 2C minus 2 2C plus 2 minus H minus X plus N. Now the molecular formula of this compound will be C6H 2, 4, 6, 8, 10, 11, 12. Oh, this is a molecular formula. Okay, so from this thing, C is equal to 6, H is equal to 12, and O is equal to 1. So IHD will be half of 2 into 6 plus 2 minus 12, and these are 0. So basically you can see the IHD is 1. Upon solving, we get 1. So question 29, our answer is option B. And for the last question, we need to find out which region of the electromagnetic spectrum is used to identify hydrogen environments in a molecule. This is a fairly theoretical question, and the answer is option D, that is radio waves. So with this, we come to an end to the solutions of IBSL 2020 Chemistry Paper 1. The next video on chemistry would be based on IBHL 2020 Chemistry Paper 2, and it would be posted very soon. So stay tuned for it, and don't forget to like, share and subscribe to our YouTube channel. Thank you so much.